Solar energy systems, we're usually talking about photovoltaics, or solar panels, which are the systems most commonly used to generate solar power. In solar panels, photons from the sun's rays hit the surface of a panel, and electrons are released to get an electric current going. Solar panels can use all types of irradiance, while solar towers can only use direct irradiance. And this is where clouds become important, because depending on their type and location relative to the sun, they can either increase or decrease the amount of electricity produced. For instance, even a few cumulus clouds in front of the sun can reduce the electricity production in solar towers to almost zero because of this dependence on direct rays. In solar panels, those clouds would decrease energy output as well, though not as much, because solar panels can use all types of irradiance. However, all this depends on the cloud's exact positioning. Due to reflection or a particular phenomenon called Mie scattering, the sun's rays can actually be focused forward by clouds to create a more than 50% increase in the solar irradiance reaching a solar panel.
We can use solar energy to power our cars, homes, businesses, and even our cell phones.
Your system is not producing any electricity. But the way that this all works is through a process called net metering. Let me show you how net metering works. In the morning, your system is producing a little bit of electricity. It's probably enough electricity to use when you need to turn on the hairdryer or make toast for breakfast. You use it as you produce it. This is also what happens during the snow. Your system is still going to be producing a little bit of electricity, and it's really just enough for you to use. Now during the day, when the sun is at the highest point in the sky, your system is producing a lot of electricity. And you're probably not using all the electricity that's being produced because you might be at work. So the additional electricity flows back into the grid. And it's going to run your meter backwards. So at nighttime, when your system is not producing any electricity, the additional credit carries over so that way you can draw it back from the grid.
Air emissions in the United States. Fossil fuel-fired power plants are responsible for 40% of man-made carbon dioxide emissions, 23% of the nation's nitrogen oxide emissions, and 67% of sulfur dioxide emissions. These emissions contribute to the formation of smog, haze, and are associated with a wide range of health problems. In addition, greenhouse gases emitted by fossil fuel-fired power plants increase the risk of climate change. In comparison, the emission from solar electricity generation is negligible, as no fossil fuels are combusted to create electricity. Let's look closely into carbon dioxide, nitrogen oxide, and sulfur dioxide. As part of the Earth's design, nature absorbs carbon dioxide. Trees, grasses, and other plants are examples of living organisms that use carbon dioxide to sustain life and grow. Simply put, carbon is the basic building block of living organisms. This brings us to the subject of carbon cycles. As a result of carbon cycles, ice ages and global warming have taken place on a global scale. What does this have to do with us today? The production of traditional forms of fuels and our addiction to them have increased carbon dioxide levels in our Earth's atmosphere, causing the Earth's temperature to rise. Currently, nitrogen oxides and 5 other major pollutants are listed as criteria pollutants. Did you know that approximately 16% of U.S. housing units are located within 300 feet of a major highway, railroad, or airport? NOx reacts with ammonia, moisture, and other compounds to form small particles. These small particles penetrate deeply into sensitive parts of the lungs and can cause or worsen respiratory disease such as emphysema and bronchitis.
our ability to use them is hard to know, but these are things that there's a set amount of them ultimately on the planet. Renewable energy sources are the ones that, if we can figure out how to harness them well, are inexhaustible. So that's wind currents, that's solar energy, that's geothermal resources, and biomass as well. Different types of plant material that we can use for either creating electric power, or if we turn it into ethanol and other forms of biofuels, we use in automobile engines.
Nick, Juliana, which